In this video, you'll see some examples that come from the IXL skill Triangle Inequality Theorem. This skill also relates to our 7.3 notes. Triangle inequalities were where we added and subtracted two values to find the possible range for the third side length in a triangle. So the first level on this assignment will have questions like this. Can the sides of a triangle have lengths 1, 4, and 4? So what I tend to do is I just find the range. I take any two of those numbers, let's say 1 and 4. I'm going to add them and I'm going to subtract them, and the third side has to fall in between those two answers. It cannot be one of those two answers, but it has to be in between. So I'm going to take 1 and 4. I'm going to add them. 5 would be the highest this number could possibly be. Then I'll subtract them. 4 minus 1 is 3. 3 is the smallest this number could possibly be. So it is bigger, this other side 4 is bigger than 3. It is smaller than 5. So yes, this would make a triangle. In your next level, you have more of the same kind of problems, but you just have decimals and numbers that are a little bit harder. You can't necessarily just look at it and know. But the process is still the same. Pick two, any two. I just go with the first two. We're going to add them and we're going to subtract them. So 5.7 plus 3.4 gives us a total of 9.1. This number should be smaller than 9.1, and it is. Since it is, I'm going to go ahead and subtract 5.7 minus 3.4, and I get 2.3. So this number should be larger than 2.3, and it is. If either of those two answers were no, if this were greater than 9.1, or if this third side were less than 2.3, or if it were exactly 9.1 or 2.3, in any of those cases, you would answer no. Again, what you're looking for is you're looking for this third side to be in between and not including the answers that you get when you add and subtract the other two sides. On our next level, again, same idea. I usually pick the first two, but you can use any two. So I'm going to add 8.4 and 1.9. My maximum side length has to be 10.3. This is less than 10.3. So far, so good. Then we will subtract 8.4 minus 1.9. 6.5 is what we get, and so this answer has to be greater than 6.5. This answer is exactly 6.5. It is not greater than 6.5, so no, these side lengths would not make triangles because 6.5 cannot be exactly, it can't be the exact answer that I get when I subtract these. When I subtracted 8.4 minus 1.9, I got exactly 6.5, and so that doesn't work. A triangle has two side lengths of 3.1 and 8.2. What compound inequality describes the possible lengths for the third side? Once again, you take those two sides, you add them, and you subtract them. So 8.2 plus 3.1 is going to give us 11.3 as our large end of the range. So I'm just going to work it backwards. I'm going to type 11.3, and then I'm going to go in and I'm going to put an X. Okay, so now I just need to subtract 8.2 minus 3.1, and I get 5.1. So 5.1 has to be less than our missing side, our X, and X has to be less than 11.3. Again, these 5.1 and 11.3 numbers came from simply adding and subtracting the two given sides. Now we're in our challenge zone. A triangle has two sides of length 20 and 1. What is the largest possible whole number length for the third side? Well, if we're wanting the whole number largest possible, right, that's going to come from adding these two together. So 20 plus 1 is, of course, 21. However, if you'll remember, my side cannot actually be 21. So I need to take the next whole number down from 21, which is going to be 20. To give you another similar example, Triangle has two side lengths of 14.5 and 1.8. What compound inequality describes the third side? Well, once again, you could even set up the whole middle part if you want to. You can put less than x and less than, and then you can just type in the number that you get when you add 14.5 plus 1.8. That's going to give us 16.3. And then out here, type the number from when you subtract 14.5 minus 1.8, and that gives 12.7. I'm going to do this one just really quickly. You've seen several examples like this already, and I would really like to find another one where we have to write the inequality. So 25.6 is our largest. That comes from adding these two numbers. And then our smallest side comes from subtracting 18.5 minus 7.1, and that should be 11.4. Okay, this is what I was wanting. A triangle has two sides of length 1 and 14. What is the smallest possible whole number length for the third side? The smallest possible is going to come from subtracting 14 minus 1, which is of course 13. But please remember your answer, the side, cannot actually be 13. So it has to be a little bit bigger than that. Otherwise the triangle won't all connect. So the smallest would have to be 14.